May I ask who of you are software architects? Okay. Who of you are only software developers? You don't design stuff. Okay. Let's do some demographics. Who are based in European EU countries? Okay. Yeah. Nice. And then I guess US and the rest of the world. Okay. Okay. What we are going to discuss today, I'm Yiannis Kanellopoulos, by the way, and this is Evelyn van Kelle. Both typical Greek and Dutch names and surnames, especially mine. If you try to pronounce it, you're going to break your tongue, I am afraid. So let's stick to Yiannis. What we are going to discuss today is how that lots of technical problems can actually be solved not in technical ways, but improving your communication between your team and its members and the project's stakeholders. That's, let's say, if I had to put a short title, and if somebody wants to leave within the next 5 minutes, this is more or less the conclusion of our talk. And this belief came from the work that we've been doing the last 10 years or so together with Evelyn, where we see lots of teams and lots of software systems. Usually we start by analyzing the technical quality of those systems, but when you start talking to people, then you realize that lots of problems can be solved with better communication rather than trying to improve the technical quality of your system or the architecture. I mean, these are, of course, essential things, but you can speed up, let's say, the resolution time, but by improving also your communication. So let's, formally start. And I'm going to do the technical. I'm going to discuss the technical side of things today, and Evelyn's going to do mostly the human side of things. She's a way sweeter person than I am, so it makes sense. So at our company Software Improvement Group, which is based in Amsterdam, this is the challenge that keeps us at night. So more or less the number of professional software developers remains stable or increases, but not dramatically within the years. So more or less we are 12 million software developers around the world. But we write lots of software. So in every year we estimate that 120 billion lines of code are being produced. And on top of what exists already, and 15% of those lines needs to be understood, it needs to be maintained and supported every year. So you understand the orders of magnitude of the problem that we're facing, and that puts at risk the digitalization of our societies these days, because everybody talks about software eating the world, about information society, and what we see is that we're producing way too many code these days, but how we support and how we maintain all these lines of code is a big challenge. So that's what keeps us at night, and now I leave the floor to Evelyn to start elaborating on the problem further.
Yes, a bit.
Please.
Thanks. So yeah, this is what's keeping us up at night. Is this mic on also? You can hear me well? Yep. Perfectly. So it's kind of our job to make sure that we're not going crazy altogether in a few years. So how do we keep this thing sustainable? And when we are talking about the problem that we're facing with clients and with our colleagues, then we usually hear a lot of stuff like this. Like, the problem that we are facing is that we're spending all this money on IT and it's still not working properly. So what do we want? Well, we want faster delivery, we want cost reduction, we want shorter times to market, and we want excellent CI/CD pipelines, because that's what's going to solve our problems. And what we need for that is, obviously, we need more developers to throw at the problem, because that will help us. But we also need microservices and DevOps and serverless architectures. And when we listen to this and when we are discussing this with clients and actually applying that to the problems that they are facing, then we see that this is actually talking about symptoms. This is not really talking about the actual problem that we're facing, like Yiannis just said in his short introduction. Because in the end, software development is a technical activity conducted by human beings. So we need to make sure that we are not mistaking these organizational problems that we have for technical issues. And we should not be talking about the symptoms, but we should be talking about the actual root causes of our problems. And when you translate that into the logic of the previous slide, then I believe, or we believe, that the truth is actually more something like this. That the actual problem that we're facing is that we are not listening to understand, but we're listening to reply. And that what we actually want is the right people talking about the right things and working on the right things at the right times. And what we actually need for that is properly working feedback loops, solid communication, value congruence, or a shared sense of reality, and clear knowledge networks. And that's how we will get to solving the real cause of our problems. Because it's really not about pretty and clever and crafty code. It's really about communication, how you work together as teams, how you collaborate as people. The future is really all about people. And last year, Yiannis hosted a keynote session at the same conference, and we were discussing that, like, great software architectures are not just about great quality code, but you also have to make sure that your systems of work, as Nick June calls them brilliantly, work in an optimal way together. So what you need happy people, happy developers. And we did some research on that as well. And Yiannis will tell you a bit more about that right now.
Right, thanks. Yeah, so some years ago I was reading a very interesting paper from a PhD student at that time, Daniel Graciotin from University of Stuttgart, who was analyzing the causes of developer unhappiness. So what makes developers unhappy? And interestingly, he created this really nice, he provided these really nice numbers, and you can see, of course, that the first cause is the difficulty of the problem. So if you try to solve a challenging problem, of course, this makes you unhappy or stressed because you need to find a solution, and that is related, of course, with the own being of the software developer, so it makes sense. But the very interesting insight is for categories 1 and 2, which I guess they resonate with most of us in this room. So the second reason is time pressure, and usually that comes from the business. So changing requirements, changing priorities at very short notice. We want this yesterday, don't delay because the client wants it. And the third, very interesting, at least for us at SAG, who are working on the code quality field, was the bad quality of the code bases. So usually as a developer, when you try to understand and support and maintain a bad code base, which is not clean, which is really messy, then that makes you unhappy and stressed. So those were very interesting insights for us. And in the meantime, together with O'Reilly, that gives us some inspiration or some ideas on how we can explore this further and understand also better the habits of software developers when it comes to quality. What are the things, what is happening right now in our industry, what are the trends. So we conducted a research in our mission to improve code quality. And we did a survey together with O'Reilly, which gave us some pretty good highlights. So if you ask, let's say, an organization who is accountable for the quality of your software systems or your software products, more than 75% would say, well, of course, the software team. These are the guys who are ultimately responsible for delivering a product of good quality, which makes some sense. But if you start digging further and you ask the same people, do you give or do you have the proper means to do your job properly? Then more than 50% will say that they don't have the means to do their job properly. So actually, for the task at hand given to a team, the organization is expecting that these guys will deliver good quality, but without actually giving them the right means to do so. And of course, we are in the code quality field. We have our own laboratory with our own systems and tooling, so we wanted to understand better how developers use these tools, or if actually they use these tools. And in that question, more than 50% they asked that they are not using code quality tools, or they don't use them, they don't operationalize them. And they gave us some good reasons for that. Lots of false positives. Usually when you use a static analysis tool, it gives you lots of warnings and violations, so you don't know where to start with. So you just drop it. I have a friend who's receiving this kind of reports from a static analysis tool, and his heuristic, if he's going to open the file, is the size of the file. So if it's more than 10 kilobytes, he deletes it. He doesn't open it. If it's less than 10 kilobytes, then he opens it. The budget, they want to buy a tool or they want to have a QA team, but the management does not approve the budget. The lack of support from the organization. The lack of support when it comes to specific technologies. So you have some rare technologies and the tooling is not providing support. And the other category is unaware. So in the organization, there is no culture for quality. There is no awareness. People, they don't even know that static code quality tools exist. So that's why they don't use them. And if we start digging further into budget, because that is related mostly with management level, organizational level decisions, then we can see that 71% of the teams, they have no budget for these kind of activities. And also by these kind of activities, we don't only mean code quality tools, we mean training on quality or workshops or more investing in the team and their ability to produce better software. 11% doesn't have a budget, and 18%, which is usually mid to junior developers, they're not aware if their organization or if their team has budget, but I guess they would have noticed if there was already something in place. So actually we think that ultimately almost 90% of the respondents in this survey, they don't have budget to improve their own their way of that they implementing software. So then we've been discussing with our clients several times on what do we mean by code quality, what we mean as a company about maintainability, and let me guide you through a little bit of our view and vision on software maintainability. And by starting with what we call the vicious cycle of unsustainable software development. So you are a developer and somebody asks you to perform a certain task, to write a piece of code. So you go to the code base, you identify the part of code that you have to change, but then it's too complex, it's heavily coupled with other parts of code, so you are afraid to touch this, so you do some workarounds, some hacks, some copy-paste, and essentially that leads your code base to grow in complexity and in size, so you have lots of lines of code that actually don't do anything, or they do less, way less than you want them to do, and and then you say, okay, we have more lines of code to support, so we need more developers, and then this goes on and on. And we see it in many cases, in many clients, and I guess people in this room can recognize that situation. And then we try to explain to the management of the organization that this is a vicious circle and they have to break it, they have to do something, because eventually it will lead to unsustainable systems or systems with high business risks. This is an alarm, which is a test alarm, so don't worry. Yes, it is, so no worries. But that's a nice break for our presentation.
Nice interruption.
Yes. Somebody doesn't agree with our message.
All
I
right.
guess it will stop in a minute. If it doesn't stop, then we all leave.
Or we die here. I don't know.
Yes.
That's...
Or we die for supporting software maintainability. Okay, okay, yeah. We're safe. Nobody leaves the room. For a moment, I thought I was going the first to leave the room. No. Okay, so we have lots of discussions. Why, usually with management, why do we need maintainable software? So, and we try to explain them that actually, when you have a software system for, let's say, on average 7 years, then 20% of your costs are putting that system into production, the initial development, and 80% of your work and the cost is on supporting that system. So the better the work that you do in the initial development, the more cost effective will be the maintenance. And as a very good colleague of ours would like to say, is maintenance starts after lunch on the first day of development. So you start the project, You write your first lines of code, you go for lunch, you go back, and you have to revisit these lines of code and change something. So if you keep in mind that this is actually a kind of maintenance, so it would be good to keep that in mind throughout the whole project, that the better the work that you do initially, the easier it is to understand what a piece of code does and how you can support it more effectively and efficiently in the future. And then the next question from the management, so we show them this and they say, okay, makes sense, but can you help us? Do you have a business case for us? I mean, what does it mean that if a system is of good quality? So at SIG, we have developed a model to rate the quality of code in stars. 1 star means bad code quality, 5 stars means excellent code quality. And we use that star rating to communicate our message about maintainability to the management, not essentially to the developers, but also to managers who don't want to understand the technical details behind the rating. I'm going to explain the model afterwards, but we did the research together with the University of Amsterdam and my colleague Dennis, who's sitting at the end of this room. These are some proper. This is technical debt. This was we have a vendor lock-in. These are owned fonts from our company and are not supported in machines which are not from our company. So anyway, this means 1 star. Actually, this means 5 stars. So if a 5-star or a 4-star system, you implement enhancements in 3 to 4 times faster than in a system or in a code base of 2 stars or 1 star. What actually we did from taking data from, let's say, the source code repositories from open source projects, but also from projects from our clients, so corporate, let's say, closed systems, we saw the correlation between the issue time resolution and or adding more functionality compared to our, let's say, model. And we saw that in code bases that the code is of low quality, everything is way slower. So by having a system of 4 stars, actually you can speed up your bug fixing, your functionality enhancement, and make sure that the system is delivered on time when we talk about a new system. So these are the argumentation, and it seems pretty convincing. So then what we try to depict for our clients is that we think that there is this holy trinity of quality. So you need a code base which is good. This essentially will lead to a good product, and essentially this means that your developers are happy, at least from the perspective of code quality, because there might be way too many causes for a person not to be happy, but we cannot solve anything for them. So this is the whole trinity, and these are interrelated. So you have to keep a balance between these 3 when you are developing a system. Now, as I said, we have this star rating about maintainability, and we give a rating. So I guess lots of you will be wondering, so how do you measure this? We have an answer. So, but before we go that, we have realized several things about how metrics are being used from our clients or from what we see in general from software development teams. So the first one is the one-track metric. So the team decides to follow just one metric to see what's happening with their code. It may be complexity, for instance, or it may be duplication, but they are not going to monitor any other metric. So this is, which of course gives you a false idea of what is happening. This is also related a little bit to the metric in a bubble, in the sense that you try to improve a metric only, like complexity, but the rest of your system might be messy. So there might be lots of coupling, and there might be lots of duplication, but then you are keeping an eye only to a certain metric. Then there is the metrics galore, which is also related to what I said before, in the sense that too many warnings, too many metrics, too many numbers, and you don't know where to start with. So actually, all these, you just simply ignore all those metrics. And the other is treating the metrics. So we have seen clients that in order to decrease the unit size of the size of their units. They were trying to concatenate all lines into one line and try to play with the brackets. So of course that's not good engineering, let's say, thought. So we keep an eye on all those pitfalls when we talk to our clients. So that's why our model is trying to solve this issue. So to come up with a standard set of measurable guidelines which we can actually quantify and use them to guide the teams in a way that is actionable. And we have, let's say, distinguish them in three categories. The first one is code. So when we look at the code of our clients, we take into account four things. The first one is the size of the units. So our advice is to keep them, to limit their size to 15 lines of code, no more than this. When you use a branching point, there should be up to 4 for every unit, because then in that way you improve the testability of your unit. You can write easier unit tests. We've seen lots of systems with branch points that exceed the number 50, or they can be in hundreds. Also, do not copy your code, no copy paste. And we have a threshold also for 6 lines, because in several languages there can be some constructs that come with the language. So we try to ignore them. We try to, because they can be false positives in our model. So we have a threshold of 6 lines and higher to consider a piece of code as a clone. And also we advise developers to keep the number of parameters to 4 in every unit, so not to exceed this number. Then we have the architecture metrics, as we call them. And there again we have some numbers, some thresholds for the developers. So if you have a module, then this should be less than 400 lines of code. About the classes, to encapsulate, hide them from other components and avoid the cyclical dependencies. Also, when you design a system, we say that your top-level components, so for instance, if you are having an e-commerce site, you can have products, you can have payments. So all these top levels should be around 6 to 12, because after that, their size increases. There's a good indication that you are breaking the system into too many components, so it's more fine-grained than you want it. And in general, your code base for a given system, for a given application, should be kept around 200,000 lines of code, excluding comments and spaces. These numbers, we revisit them every year, and we calibrate our model because we are obliged to, in order to give, let's say, a rating which is scientifically proven. And we've been audited by TÜV-IT, the German auditor, every year if we follow scientifically proven methods for all these measurements. And the trend that we see in the market is that these thresholds become stricter and stricter. So more developers are being aware, especially the ones working with newer technologies, and they try to set up CI/CD processes. These guys, they try to keep everything at a really manageable level, so they can write unit tests more easily. And then the third category that we look is the way of working, actually. And of course, the first is the testing automation. So if you write code, please write automate tests that cover all the code, not only the 80% as we say in the industry, but try to cover as much as possible. And when you write a production line of code, then it should be accompanied by the respective testing line of code. And then also we say that stick to the 7 Boy Scout rules, with the overarching rule of everything you touch, leave it better as it was before you touch it. So these are all the 3 pillars that we see from a technical point of view. And now, because I was too technical, let's discuss the social side of things. So Evelyn?
Yes, thank you. Yes, great. Yeah, so let's talk about the social dynamics for a bit. Because social dynamics, they are everywhere, but they are especially present in our software architectures. So if we understand which dynamics are influencing our work, the way that we work, and our actual technical choices in our designs, then we can make them work for us, and they won't be any hinder to us. So I listed a few of the sociodynamics that are influencing our architectures. And this is not even all of it. These are just a few that I think are important. And don't worry, I'm not going to discuss all of them because I narrowed it down to 3, of which I think are really affecting how we work and our technical choices. And if we understand how they work, then we will understand a lot more, actually. I really like this quote from Martin Fowler, because in the end, we are not writing code for computers, but we are writing code for human beings. So our team members need to know what we're doing, why we did certain things. And if people leave or team members are being replaced, then it still needs to be clear what was happening in that code base. And that also has a lot to do with Conway's Law, and Conway's Law will be familiar to, well, I think most of you, if not all of you. And it says that the way that we architect our software mirrors the way our organizations think. So if you want to improve our software architectures, then we also have to at least reflect on our communication structures and our organizational effectiveness and see how we're doing on that level. Because if we understand that and if we know what's going on there, then we can, for example, better understand a thing that we very often see at our clients, and that's the deviation or the mismatch between plan and reality. This is not something that we made up. This is actually data of a client of ours. And it basically tells us the difference between what a client designed for and what they ended up with. And that's kind of a, well, pretty particular mismatch, but it's not uncommon. It's happening all the time. So when we ask our clients, like, how did this happen? How did you end up with the thing on the right when you wanted the thing on the left? Then we usually not get a lot of constructive answers, and we get a lot of different answers. And that tells us that not everyone knows what they're working on or why certain choices were made, so not everyone knows their IT landscape. And that can be a problem. And I'm not saying that there's anything wrong with deviating from a plan, because that makes sense, and sometimes you should definitely do it, but at least you have to know why you're doing it. You have to know why you're making certain decisions. And this is all easier in hindsight, and of course for our clients, we look at their source code and then we reverse engineer the design that's in there, and we compare that to what's in front of us, and then there are all these interesting discussions. And there are a lot of reasons for this mismatch, but one of them is malfunctioning communication structures, and especially missing feedback loops. So if we want to avoid this, then I think from a social perspective, we need at least 3 things. And that's properly working feedback loops, or strong feedback loops, a shared sense of reality, and clear knowledge networks. These are the 3 social dynamics that I'm going to discuss with you today. So starting with feedback loops, because if I ask you, do you want to improve your communication structures? And everyone would like to say, yay, of course we do. How do we do that? Communication is still kind of a vague concept, and feedback loops are a way to make it a bit more tangible, to make it a bit more visible how you're communicating and collaborating as a team. And this is a very important thing that we really need to reflect on. Welcome. So if we think about Conway's Law, then we need to somehow find a link between the feedback loops that are in our communication structures and the designs that we are working on. So starting out with a very simple feedback loop. This is a developer, a system. The developer gives input to the system. Then by testing, he gets some feedback, and he or she, I'm not stereotyping here, can decide what the next steps will be. And this is really a simple loop, and our projects that we're working on and everything that we're doing is way more complex than this, and there are lots of more people involved. But to illustrate what happens if we only add one more person to this mix, and let's say we add an architect here, then things will become way more complex instantly. And then we often see something happening like this. It's the tower syndrome, and of course this is all exaggerated, but it's to make a point. And then sometimes we see this architect who is sitting in his ivory tower designing the architecture, and then when he's done, he's like, now I'm handing this over to you, developers, and create something and implement it. And then there's not really any communication or feedback or retrospectives between the developer and the architect. So the architect thinks, I'm done, this is my design, please implement it. And the developers think, well, why did he make certain choices? Why did this happen? Why are we implementing this? And the architect, after a while, looks at the actual architecture in front of him and thinks, well, this is not really what I meant with that choice. So this is becoming instantly increased complexity. And when you translate this picture into a feedback loop, or when you try to do that, you get something like this. And this is not a loop anymore. So the architect is not getting any feedback from the developers and nor from the system. So that can be a real problem. So a solution here could be, and that sounds really simple of course, but just to be actively aware of that everyone is involved in the implementation cycle and that you're not leaving people out. There's this one thing that makes everything even more complex, and that's a tendency that we have as humans to include as much people as possible in one feedback loop. I mean, we all have lots of emails in our inbox with people in CC of which we think, well, was that really necessary? So that's happening a lot, and we should try to avoid that because it will let us end up with something I'd like to call feedback chaos. And that's this. So these are not feedback loops anymore. And this is kind of a problem because there's just way too much going on in this picture. So it's really hard to keep control of what's going on here, and communication lines won't be effective at all. And if we think about Conway's law, if our communication structures look like this, and that's mirrored in our architectures, then that might be kind of a problem, and it will end up in a gap between plan and reality. So if we want to solve this, one of the first things that we could think of, we need to structure this. We need to organize this thing. We need to make sure that we have separate little feedback loops that are working beautifully together. I would suggest not to, because that's kind of an unrealistic goal and it will really leave you with a lot of frustrations because you will be spending way too much time trying to organize this thing perfectly and you won't have time for any other thing. So the trade-off there is just really something you have to think about. So what we could do, I like to use this visual because this basically tells you why having a lot of communication lines won't work. And the visual basically tells you why flat organizations will fail. And that's because there's just way too much going on, way too much complexity. And sometimes people think it's kind of cool to say, well, I'm in a flat organization or a flat team and I don't really have a manager. But that will make things way more complex. So we will have to organize and structure ourselves to some extent. Because the visual suggests adding even more than 7 people will make it already really hard to communicate effectively. And if your communication structure looks like this, then you will definitely end up with feedback chaos. So I would suggest don't do it. So the goal here is to get to some sort of a manageable, controllable situation. And you could use an organizational chart for that. You really have to reflect on how your teams are structured at this moment. Are teams really making sense? Who needs to be in a feedback loop or a communication line with whom? Who needs to talk about which topic with whom? It's just a matter of really reflecting on what your team structures look like right now, and then see if you can optimize for that. And when we're talking about feedback, we are talking about personal and tool-based feedback. So there are kind of 2 things. And Yiannis has a case study on that as well that he would like to discuss a bit. It's a short one, yeah. It's an intermezzo.
Yes. So we receive lots of times questions from our clients. I mean, should we do peer reviews or should we use static code analysis tools? And for us, this is a false dichotomy. It's a false dilemma. You shouldn't combine them. It's not one thing or the other. Each has its own advantages, so make sure that you try to combine the best of 2 worlds. So when you do a peer review with your team, with your peers, then of course this feedback is specific to your project, so it's not something really project agnostic or language agnostic or a model from a company like ours, for instance, but it's really hands-on to what you do. Also, it's more context sensitive, so the persons understand the nuances, understand the specifics of the situation. And also, when you look at a certain piece of code, then the discussion is really concrete because you have this, and you get specific instructions on how you can improve it. On the other hand, with using a tooling, you can have a faster feedback loop, and also you can have the overall picture of the system within, let's say, a very short amount of time, and which of course makes things more scalable for you. So it's not like you look individually at certain pieces of code, but you get the overall picture of the system. And of course, if you use the tooling combined with some model and a benchmark, you make things more objective, so less politics. This is something that we do with our clients. If we come as a third party and we say the quality of your code is this, then there is no pushback on why did you measure the system in that way or in this way, or should we exclude this module because we don't use that much. So let's exclude this complex piece of code that gives a more negative picture. So and we've seen it several times with clients. So we wanted to have something that was making a more convincing argument, and we wanted to connect it also to our model. So we had this client that it's a team. It was a project. They were building a new omni-channel solution for their bank. It was a team of 40 developers. Now I think there are 100, and it was a mixed team. So some guys from Accenture combined with some people from the bank, but they were like as a team. So it wasn't Accenture and the bank. And in the beginning of the project, so you can see that we've been monitoring the quality of the code for some time now. I mean, already something like 3 years already. And in the beginning, everybody was really enthusiastic about quality. We had our workshops. We explained about the model. We did our trainings. Everybody was really on board. So the quality of the code was really high. But then the business came and they started pushing requirements and pushing them to deliver as soon as possible. So the quality dropped from 4 stars to 3 stars. And it was at that level. 3 stars is like market average. Typically you want to be at 4 stars level or more than 3.5, let's say. And at a certain moment, then the months were passing, we would see some improvements, but not really spectacular improvements. So we sat together with the team and said, guys, I mean, what do you do with our tooling? What do you do with our monitor? I mean, do you actually use it, or you try just to make it sure that the quality doesn't go below the 3 stars, whereas your KPI from the management is 4 stars. So you don't want to screw things even more, but you want to keep it in acceptable, let's say, more or less level. And we understood that the team, although they look on our findings, they don't discuss them between each other. So it's the architect and the team leads that they look at these findings, and then they go and they have a fight with the team, but actually they don't do something with these findings. So I said, well, why don't you start doing some peer reviews, more, let's say, systematic, and then use the input for our monitor. We can distill the information for you, can tell you what are the most complex parts or what are the candidates for refactoring, and then you discuss these findings with your team, and you guide them how to improve them. And like overnight, like within 2 or 3 weeks, the quality was improved to 4 stars level, so more than 3.5, and it's constantly there. And so for us, that was a really nice example. Also, the management liked it, although they had to, their costs increased because they had to hire some extra guys for the peer reviews. They were pretty happy that this paid off in that way and at a very short time frame, because what they are afraid is that this project, because it's growing in size, they don't want to have lots of technical debt. And in that way, they see they can manage at least the technical debt in their code base. And it's a good example of how you can combine specific findings from a tool, which comes with a benchmark, so some objectivity, so you erase the political discussions about the code, and then you help the team focusing on the stuff that really matters for improvement. That was my intermezzo. So
then we're going to discuss the second thing on the list that's affecting our architectures, and that's value congruence. And value congruence is just a fancy term that social scientists like to use. It means that you are living in a shared sense of reality. The thing with value is that we all have them. We have business values and personal values, and we base our actions and our behavior on these values that we have. So when we're working in a team together, then it's kind of convenient to have a shared set of values that you're working on. And values can also mean shared metrics and standards, so definitions of done and techniques. So it's kind of convenient to have, at least at the beginning of a project, but not only at the beginning, throughout the project as well, to reflect on these values and make sure that you're still aligned. Because teams that have these shared values, these shared metrics and standards and stuff, they are really more productive than teams who haven't. So we are all familiar with the anti-patterns of value congruence. We are either all heading in different directions and not really know what we're doing, or we are stuck in meetings all day trying to be as aligned as possible and not getting any actual work done. And these are both situations that we want to avoid. And that is why we probably need autonomous teams that are not too depending on each other and don't need to be aligning all the time. And if, of course, you're not getting to autonomous teams overnight, that's something that takes a lot of time. And when we're trying to do that, then one of the first things that we have to consider are domains. Are we going to organize our teams around business domains or technical domains? And both have advantages, both have benefits, of course, but when it comes to creating this shared sense of reality, then I think it's easier to do that when you're organized around business domains. And that's because there will be a better fit with the rest of the organization and its goals and its vision. It will also help you smoothen the conversation between IT and the business because you're talking about business domains, business problems, instead of getting to the solution or the technologies right away. And when you are organized around technical domains and everyone has this expertise and you're thinking from that expertise and you're acting based on that expertise and based on what you know. So it's kind of harder to create a shared set of shared values in there. So what kind of people do we need then in these teams? And there's no silver bullet for that, unfortunately. But there is this thing called T-shaped profiles. And that means that you can have in-depth knowledge and more broader knowledge on business domains or technologies. And this is really black and white. I mean, these are two ends of a spectrum, but when you want to create the shared sense of reality and you want to create autonomous teams, and it might be more convenient to have people oriented towards the left T, oriented towards. So it's not like you have to be either one of these two. But it might help you better define the problem instead of talking about and thinking about solutions and technologies right away. That also has a lot to do with how we make decisions. We base our decisions on what we know. We base our decisions on what's familiar to us. So if I have really in-depth knowledge about a certain technology and we need a new application, then it makes sense for me to think about the technology right away. Well, I build it in a technology that I know because that makes sense. That kind of relates to the keynote that we heard this morning, like why are you using microservices? Well, my manager told me to, so I will do this. But when you have some in-depth knowledge about business domains, you can really define and formulate that problem better, and that will help you think of a maybe better solution. It will at least help you in making less biased decisions, and that will really help you there. So when you want to know more about that part, the autonomous teams, well, I would really recommend this book. And it's not just about designing a system, it's also about designing your system of work and creating autonomous teams. And this inspired me for a big deal. So if you want to start somewhere, if you want to know more about this, then really you should read this book. The third and final thing that I wanted to discuss are knowledge networks, because all these people in these teams, they have a lot of knowledge. And lots of it is explicit, but even more of it is implicit. And that doesn't have to be a problem, because if you're in a team and you have a certain problem and you know, well, that person knows a lot about that topic, I'll just go there, ask him or her for help, and then we can solve the problem. But what happens when that person leaves or is just way too busy helping you? Then you have a problem. So you have to find a way to somehow make this knowledge distribution explicit in your teams and in your organization. A first distinction that I then like to make is information and knowledge. And information is just data and facts, and it's tangible, and you can grab it. It's straightforward. And when you put that into context, when you connect it to experiences and practices and people, then it becomes knowledge. And knowledge is crucial in the work that we are doing. So to make it even harder, we have two types of knowledge. We have explicit knowledge and we have tacit knowledge. And explicit knowledge, that's just the tip of the iceberg. That's the know what knowledge. And it's kind of related to information, but with a little bit more context. But it's easy to grasp, and you can easily you can transfer it or you can share it. It's easier to document. But most of what we know, most of our knowledge is tacit, and especially in our software development projects. And that means that it's knowledge that lives in people and their practices. And it's not something that you simply write down when you have 5 minutes left at the end of the day. It's really hard, but this is the knowledge that we are depending on in our projects. So if we know how this knowledge in the heads of people is distributed between our teams, then that will really help us, right? Because if teams change, or if people leave or are too busy, or we are depending way too much on one single person, then we have that knowledge somewhere documented. So that will help us. And it will, for example, help us identify bottlenecks. And you can see, well, maybe there's this one person from one team that's working on a certain topic mostly, but then there are all these communication lines between him and the rest of the team, but not only his own team, but also there are other teams that are depending on him. So maybe this key player holds some sort of a knowledge monopoly that's holding us back from getting this delivery faster and getting this time to market shorter. So that's cool. And the question then, of course, is that's very cool and all, but can we measure this? And the good news is that we can. And we do that, or we're trying to do that by using these underestimated gold mines that we use a lot, but we use them to say something about the technical quality of stuff. But we almost never use them to say something about social and behavioral patterns. But version control systems, source code and ticketing systems, they contain a lot of social data and behavioral data. And we should definitely start using them more to get these insights. Because the beauty of it is that we are not saying something based on subjective things or vague concept, but we're actually saying something about how we collaborate as human beings based on data, on source code. And I get really excited when I'm working on that and when I talk about that. Because it can really help us answer a lot of questions. Because these sources, they contain time dimensions. So we can see who did what to which system or which component and what technology, what time. It contains a lot of data. You can also say something about how the knowledge is distributed between teams. And then you can create all sorts of really cool visuals with that. And we are working on that in SRG. One of my colleagues, Pepijn, who is in the back, he's playing a huge part in that. So this gets really cool, and I wanted to share one visual with you guys, and that's this one. It's taking a bit to load because there's some heavily manual work in here. So this tells you the changes that were made per developer over time, and the colors in here are the different components, so you can see who has been working on what. And this is anonymized, of course, but there are lots of questions that you can answer based on this data. And this is what really can help us in visualize how teams are collaborating and how knowledge is distributed. And it can help you answer so many questions. So a few of them I listed on a slide, but this is just what fitted on the slide. So there are lots of more questions that you can answer. But we are really excited about this, and we are exploring this, and we're trying to get even more social and behavioral data out of the source code and out of the version control systems. And that is really going to help us balance this social technical complexity in the future, and it will really make our products better and of higher quality. This slide kind of marks the end of our presentation. So if you wanted to talk more about this or any other of the stuff that we just discussed, we also have a booth in the sponsor pavilion. And we are here with a lot of colleagues from the software improvement group, so don't hesitate to contact us and to come over. So if you have any questions, then Yiannis is happy to answer them. And that's the end for us today.
There is 5 minutes left. Are there any questions?
Yes.
Do you have any advice on introducing the quality code metrics on a large system? Where do I start? What's the best way to prove value so I can do it for the overall system?
Yeah, I mean, from a technical point of view, usually we see that, for example, duplication of the code base is something that we can call as low-hanging fruit. I mean, you can identify lots of clones that actually they are 100% or 99.9% identical. So these are your first candidates for reusability, let's say, so creating a common or a library or a common component. That's from a technical point of view. So intuitively, I'd say duplication. But also from a business point of view, you need to identify which component is more crucial or the one that is most problematic for the business, so you can start fixing things from there. Yes, please.
Is there any automated tools to gather the metrics that are shown, except for, of course, the communication metrics and so on?
Currently, no.
No, not yet, but that is something that's a logical next step. Yes, definitely. Yeah.
But we're working on it.
Yeah.
Okay.
I don't know who's first, but just yeah.
Would you adapt those figures that you had on your code quality metrics depending on the language?
Because we are being audited by 2FIT based on a specific standard the whole model should be language agnostic and technology agnostic and paradigm agnostic, which means all these thresholds, all the numbers should be horizontally applied to any technology. But that's why we have the calibration, and we have a certain way to calculate all those things, and we compare the measurements between all the systems. So then the whole rating comes as a reflection of the whole industry, of the whole set of technologies that we analyze. So we try not to penalize technologies that are more verbose or they have some specific constructs that might not make your life easy. Yes.
You have these metrics which tell you where you have poor code quality, but part of the feedback was developers saying they didn't feel empowered to correct those issues.
Yes.
How do the metrics empower the developers?
The metrics indicate and make visible a problem. It's as we say, you cannot control what you cannot measure. So if you start measuring, then you start identifying your pain points, and then you need to act. And the metric will help the developer going back to the management and say that we have some problems in our code base, and these are the areas that were most problematic, and this is the effort that we need to spend to improve that. And that's so you make the discussion more concrete with your management to get their support and their buy-in.
How do you measure the outcome of that?
No, we don't measure it, right? I mean,
In terms of the outcome of, you mean of code quality or?
Improving code quality.
yeah,
you can measure that.
Yes, that
yeah.
we measure. Sorry, I thought
Yeah.
that the business, let's say, improvement, how we measure. We don't measure, but the quality, as I said, in the case study I saw with the graph, typically we work with our clients for some time, and we keep monitoring the quality of the code base every month or every week or every second week, and we can identify the improvements. We can testify on them. There was a yes.
One more question.
So you said about architecture, keeping your architecture down to 200,000 lines of code. So if you were being very efficient and then but you were at that limit, how do you handle adding functionality?
Well, our position is, of course, not to start removing business functionality from your system to make it lean, right? But if, let's say, you build an application and it starts growing really fast, or it grows a lot, then you might reconsider whether this needs to be broken down in smaller applications instead of trying to put more functionality in the same code base. So it's mostly an indication that you might want to start breaking things in smaller pieces, not that you need to remove business functionality from your code base. So it's an indication for separating systems.
So I suppose the follow-up to that would be, when you say architecture,
Sorry?
when you say in that diagram architecture, what constitutes architecture in that? Is that the entire system function, or is that an individual repository?
It's the whole system, how you design it.
The whole system, you mean, are you splitting it into domains? Because if you say, okay, I don't know if these 200K of lines are architectural agnostic or not, but you say, okay, I'm moving from a monolithic approach to a microservice approach, which are from specific domains.
Mm-hmm.
Would you then apply 200K of line to one domain, or also to this whole previous monolithic approach?
That's a nice question. Currently, our model is mostly on the application level, but we are doing some research to see how we can adapt some things towards the microservices architecture.
Yes.
Okay. I think we have to.
Yeah.
to
If there are more questions,
yes.
then we are happy to answer.
We will
them.
be around, so you can.
Yeah, we will.
Yes. Thank you.
Thank you.